Good morning. My name is Galip Ulsoy. I'm a professor of mechanical engineering at University of Michigan, and I'm here to give you a preview of the course ME568 Vehicle Control Systems, which will be taught at University of Michigan this fall term. ME568 covers four major topics. First major topic is an introduction and background. Why do we need vehicle control systems? A background on automotive systems, control design, some background on MATLAB, Simulink tools, vehicle dynamics, engine modeling, and human factors. Second part of the course covers powertrain control, things like air-fuel ratio control, spark timing, idle speed, transmission control, as well as hybrid electric vehicles and fuel cell vehicles. The third major part of the course is focused on the control of the vehicle itself, things like cruise and headway control, anti-lock braking, traction control, vehicle stability control, four-wheel steering, active suspensions, and so on. The last part of the course is intelligent transportation systems, which looks at control technology not only on the vehicle, but also in the transportation infrastructure. So we'll talk about topics like active safety to prevent accidents, automated highways, platooning, automated steering. Why should this course be of interest to you? First of all, very important in terms of safety. On average, one person dies every minute somewhere in the world due to a car crash, and there's tremendous economic costs associated with these accidents and fatalities. Also, we've all experienced delays due to congestion, particularly if you live in major urban areas. So advances in control can help address such issues of safety and congestion, as well as improve emissions and improve fuel economy. Some examples that most of us are familiar with, engine controls have had a tremendous impact over the last few decades on fuel economy and emissions. Safety technologies such as airbags, traction controls, anti-lock brakes, and so on have ensured that fatalities have not increased in the U.S. despite the fact that miles driven has increased dramatically. Also, there are technologies that provide passenger comfort, such as active suspensions, and ease of driving, things like autonomous cruise control systems or cruise control. And there are many others. Some are currently available on commercial vehicles, and others, such as fuel cell technologies, are under development. Here's a couple of quick video clips to give you a sense of some of these technologies. This one shows a camera next to the rear view mirror in a car that's used to detect the lane edges and can give a warning to the driver when the vehicle starts to depart from the road. So these lane detection and lane warning systems are being used, for example, on long-range trucking. Here's another example from a demonstration in San Diego a few years ago that shows a platoon of vehicles on a highway. These are all automatically controlled. Their relative distances are maintained, and there's inter-vehicle communication, which allows them to act together as a platoon and avoid problems of congestion and provide increased throughput on the highway. So the objectives of the course are to provide a graduate level introduction to vehicle control systems. The students taking the course will be introduced to basic concepts and terminology, the state of the art in each of the fields, and basic methodologies. And upon completion of the course, they'll be able to read the literature on the subject and to do independent design, research, and development work in the field. So before you take the course, you want to make sure you have the necessary background. The prerequisites include a first course in dynamics, which at Michigan is ME240, and a first course in automatic control. Again, at Michigan, that's ME461. These two are really essential prerequisites as we'll be building on this material quite extensively. It's also important to have some familiarity with MATLAB and Simulink. We'll be using this extensively for homeworks and projects and other assignments. And if you'd like to study some of this on your own before you take the class, the link here provides a nice online tutorial that helps you learn MATLAB and Simulink. It's also nice if you have some background in automotive engineering and automotive electronics, although that's not required. As far as how the course is structured, the grades will be based on homework, projects, and a final exam. And there's a course website and all the course materials, the presentations in class, the handouts, as well as a complete set of course notes will be provided through the course website. The course notes are based on a forthcoming textbook which will be published later this year on automotive control systems, so they're fairly complete and up to date. So I hope that helps you understand whether you're interested in taking ME568. If you have any further questions, please don't hesitate to contact me. Here's my contact information.